Okay, so now we're looking at linear functions. Now, what is a linear function? If you look at the root word for linear, it is line. So a linear function is simply a graph that creates a line. Now, sometimes you won't have a graph and you just have a table or a chart. So we're going to learn how to identify a linear function without graphing. So I'm going to show you how to identify it without graphing, and then show you on a graph if it is a linear function or if it is not a linear function. And so basically, to identify whether or not this is a linear function, looking at the table, you want to look for a constant change in x and a constant change in y. So these are my x values. These are my y values of my ordered pairs. So if I go from -2 to -1, what happens? I am adding 1. If I go from -1 to 0, what happens? Again, I'm adding 1. 0 to 1, adding 1, 1 to 2, adding 1. So I have a constant change with my x values, but I also have to have a constant change to my corresponding y values. So let's see what happens. From 7 to 4, I'm subtracting 3. From 4 to 1, subtracting 3. 1 to -2, subtracting 3. -2 to -5, again subtracting 3. So as you can see, there's a constant change in my x values, adding 1, along with a constant change in my y values, subtracting 3. So yes, this is a linear function. So just to show you on a graph, if I were to graph these ordered pairs, it should create a line. So I'm going to graph -2, 7 first, back to -2, up to 7, right here, -1, 4, right here, 0, 1, 0 and 1 here, 1, -2, over the 1, down to -2, and 2, -5, over the 2, down to -5. I think I made a mistake. 1, -2 should be right here. There we go. So now this graph, in fact, creates a line. Let me just get my ruler to draw my line a little more precise. So as you can see, try to draw it through all of the points there, but it's a line. So that graph does in fact create a line. But if you do not have a coordinate grid, if you just simply look at the table and look at the constant rate, it is a linear function if your x values change at a constant rate and if your y values also change at a constant rate. All right, so let's try another problem here. Again, we want to see if there's a constant change in my x value along with a constant change in my corresponding y values. So from -2 to -1, again, we're adding 1, -1 to 0, adding 1, 0 to 1, adding 1, 1 to 2, adding 1. So I do have my constant change with my x values. Now let's check to see if there's a constant change with my y values. 6 to 3, I am subtracting 3. 3 to 2, subtracting 1. 2 to 3, adding 1. And 3 to 6, adding 3. So as you can see, there is not a constant change with my y values, so this is not a linear function. It does not create a line. And just to show you on the graph, I'm going to plot the points here. -2, 6. -1, 3. Back to -1, up to 3. 0, 2. 0, 2. 1, 3. Over to 1. Up to 3. And 2, 6. Over to 2. Up to 6. And this actually creates something that is called a parabola, but definitely not a line, so it is not a linear function. And honestly, I could have stopped right here when I saw that this was not constant, I could have made the conclusion that this is not a linear function, but just to show you even more why it is not a linear function, you could keep going. All right, so now we've shown that this part here, or this graph here, or this table here, does not show linear functions.